Prisms and cylinders. Today's cones and pyramids. Volumes of cones and pyramids. So you guys go back to your formula sheet and you look at the pyramid. Compare that to the prism we did yesterday. It's pretty similar, isn't it? Look at the prism and the pyramid for me. It's pretty similar. The only difference is the pyramid now we multiply by 1/3 BH. And give me a minute here to get animated. Let's remind ourselves what that capital B and H means. Capital B, same thing it meant yesterday, which was what? Calculate B, area of the base. Again, I can't tell you guys what the shape's going to be. It could be a square, triangle, and we know a hexagon. Whatever the base is, find the area of it. And here's where I'm really going to get jacked up today. The H. And yeah, it's easy for you guys to say, oh, that's the height. All right, but we're talking about a pyramid. Pyramid, remember, I went nuts on the middle desk last week. We had 2 heights, didn't it? That's not slant height. That's the height you drop your rope straight down to. That's the height of the pyramid, not slant height. And in parentheses here, I'm going to put altitude if that helps you. Put Mission Impossible height if that helps you. But everyone knows what I'm meaning here. And the H in 1/3 BH is from the apex, that point on the top of the pyramid, straight down. That is the H in 1/3 BH. All right, let's try one out. This is our only basic one here for a pyramid. Find the volume of this basic pyramid. And then we're going to get a hardcore, as you know. So 1/3. Let's start with capital B. I need somebody in the audience here to calculate the area of the base for me. It's a square. It's a square pyramid. What's the area of the base there? Area of my base, where are we rocking here? Henry, good talk. Let's keep going. Alyssa, what's the area of the base? 100, 10 times 10. Everyone's good? So 1/3. I'll even put 10 times 10 there for you. All right, everyone ready for H? You going to plug in 13? No, what's 13 called again? Slant height. I need the altitude. Yep, little Pythag coming in. Remember this? Draw it down. It forms a right triangle with the slant height. And then anybody remember how to calculate that other leg there? That's always half the base. All right, go ahead. Now we can do Pythag with H, 5, and 13. Char, what do you have for the height? 12, good. So we got 12. I plug that in to the height of for the volume. And I'm not even going to ask. I know you guys can punch buttons fine. What's that, 400? Yep. 400, just remember your units. We talked yesterday, if anybody wasn't here. Now it's cubic units, not squared units, cubed units. Anything I can answer about that basic pyramid, because now it's going to get more advanced. All right, let's keep rolling with number 2. Regular pyramid, square base. If anybody wants a visual, that's what we just dealt with in number 1. That's a regular pyramid with a square base. Perimeter of that square. Perimeter. 36 inches. Perimeter, 36 inches. And the height of the pyramid is 15. Now, I know, and I understand some of you, well, what height are you talking about? Hey, did I put the word slant in there at all? No. So that's the height. The height. If I want slant height, darn it, I'll write the word slant with it. This is just the height of the pyramid is 15. What's the volume? All right, so let's go. Volume, 1/3, base times height. We already know the height, so substitute that in. Height's 15. We're not substituting in 36. That's the perimeter. What's capital B stand for? The area of the base. So I need your help going from the perimeter to what's the area of this square? Square. Square. What do you know about all 4 sides? They're all equal and they all add up to 36. Can you find at least a side for me? All right, find a side. All four congruent sides add up to 36. It's already doing it for me. All right, what's each side length then? Perimeter is 36, each side length. We'll get it. No, we'll get it. Look at all these smart. Oh, come on. Yep. Ha! Alyssa. 9. Thank you. What's the area now? It's a square, length times width. What's the area now so I can plug it in for capital B? What's my area? Oh, boy. Nope. It's going to be fun today, kids. Test, relax. 81. Good job. 81. Everyone all right? 9 times 9? $405. Look good? For the volume of this pyramid, what do we got? Inches cubed. Whew. That's nothing. That's nothing. You're just sniffing how hard it is right now. Anything before we get to my good old real life example here? Talk about this bad boy in global at all? This great pyramid? What do we think? Giza? We had that debate first period, so we had to figure it out. We had to end it and actually figure it out. So, of course, I Google Pyramid of Giza, and I get all these cute pictures, right? Well, I had to do pronunciation because that was here, but anybody who is wondering what these bad boys look like, there you go. Look at all those. Look at that, huh? Look at that compared to the, what do we got there? Pisa, Leaning Tower of Pisa, Statue of Liberty, what's that, Big Ben? Might be, I'm just guessing. That's why I teach math. Everyone take a look at those, huh? Everyone good? Now Giza. So then I typed in pronunciation, and the first thing that came up was this YouTube video, which might be, just a disclaimer, the creepiest video I've ever seen. All right, so hopefully you guys don't have nightmares tonight, but here's why. Really pronunciating, in case anybody didn't know how to say the. There we go. I can't turn it off. It's like a car wreck. All right, there you go, Giza. All right, if anybody wants to go and because you're a freak and want to watch that later on, go ahead. All right, it's a little creepy, but anyway, I'm giving you the volume. Pretty big pyramid, right? Look at that, 2.5, about 2.6 cubic meters. That's a pretty big pyramid. And a height, again, I don't say slant height. We said height of 146.5. What's one length of their base? All right, this is going to be involved here. Take it one step at a time. I'm giving you the volume, and it's a pyramid, 1/3 BH. We'll start there. You know the volume. Substitute it in for V. Be careful when you write this. We had a couple students in my first period class add a couple 7s at the end, and it threw off their answer. User error. All right, volume equals 1/3. I'm going to have you solve for B. That won't be my answer when we know H is 146.5. Okay, so we're going to solve for B right now. And then we're going to talk, how do I get the side of the base from capital B? All right, so go ahead, get the 1/3 out of there, get the 146.5 out of it. I don't want to tell you how to do it because you could do it in a couple different ways. So get the 1/3 out of there somehow. Get the 146.5 out of there. Get B by itself, please. And we'll see if our answers match. Okay, anybody 53,084? Let me know before we move on. That's not my answer. I'm not saying that's my answer, but that's what we should get for capital B. Vinny, did you get that? Because I know your calculator. Who knows what language it is in today?
I did get
Okay,
it.
all right. I'm proud of you. I'm proud of you. Baby steps. Got to crawl before you walk, right? Everyone's good here? Yes, no? We can go over how to get to this point. All right, what did we just find? What's capital B represent again? That's my area of the base, right? That's the area. We need to find one side. Now, do not think this is like the last problem. I'm telling you the area, not perimeter. Not perimeter. So I'm not dividing this number by 4 to find the side. The area of this square is 53,084 point. Yep, I'll write it all in because that's what I tell you to do. That's the area. So we're not dividing that by 4. So let's talk. How can I get to the area to one side of the square? Again, what do you know about a square and their sides? They're all equal. How do you find the area of a square? What's the quick formula? Base times height, length times width. And they're both the same. So think about it. They're both the same, and it's length times width. So this will be x times x, which is also known as x squared, right, everyone? So x times x equals your area. So I'm not dividing by 4. What do I actually need to do in my calculator to get one side now? Take the square root, correct. So perimeter you would divide by 4, but now that I know the area, I want to take the square root. That's how I'm going to find the side of the square. And after you do that, there's still one catch to this problem that I'll see if you pick up on. So take the square root of your area to get to the side. And what do we round it to? Nearest meter? Everyone getting about 230 if you round it correctly? All right. What are my units? Units? Should I cube them? No, right? I didn't find volume. I'm just finding a side length. So it should just stay just meters. Good. All right. I only cube them if I find volume. Woo! All right. Everyone good with pyramid? That was pretty involved. Jesus. I know you're don't get nervous. Cone's not that bad. All right. Everyone ready for a cone now? All right. Cone. Same formula as pyramid. It's 1/3 BH, but let's be honest here. What's the B? What's the figure on the cone? What's its base? Circle. So instead of putting B, you go to your formula sheet. It doesn't have 1/3 BH. It has what in for B? 1/3. It's a circle, even if you're not looking at the formula sheet. Pi r squared, because that's the base times height. Again, H, still the height. Height, altitude, not slant height. Not slant height. From the tip all the way down to the middle of the base. All right, let's roll. Basic cone problem before we get more involved. Leave your answer in terms of pi, please. For part A, leave your answer in terms of pi. 1/3 pi. We don't have r, do we? We're going to have to talk about how to get r. We do have h, though. Out of these two, what are you plugging in for h in 1/3 pi r squared h? Out of these two, which one's the height that we need? I know they're both heights, but which one are we going to use here? Drew? 15. Thank you. 15, because that's the height. 17 would be the slant height. So we're going to use 15. And everyone ready to find r using Pythagorean theorem? 15 squared plus your radius squared. 17 is now the hypotenuse in that right triangle. I'll ask somebody what you got for the radius here in a second. Shara, radius length when you have it? 8, good work. So let's plug that in for 8. All we're doing is leaving this in terms of pi, which your calculator does for you, of course. I don't need to ask anybody there. (320 pi) cubic meters. And then part B, what's the volume rounded to the nearest tenth now? And I'm just asking this, trying to get you ready, making sure we're good with rounding for the regions, because that's silly points taken off if we don't round correctly. So 320 pi rounded to the nearest tenth. Finley.
1,500.
Thank you. All right, all good? Ready to keep going a little bit more advanced now? Problems? Volume of a cone. All right, 1/3 pi r squared times the height. Okay, now I'm giving you the volume. So everyone substitute in 96 pi for V. I'm giving you the volume. And, whoa, wait, oh, jeez. It's asking for diameter. Can I even do this problem? My formula doesn't have diameter. Can I even do this problem? This even doable for me? Fun day here today. Zoli, can I even do this problem?
Yeah.
How?
By timing the radius by 2.
Oh, okay, I get it. Solve for the radius and then times it by. All right, so let's solve for the radius. Height's 8, so that can go right in. I didn't say slant height. You guys notice what's on both sides, whether they're going to cancel out in the first or the last step. The pi's can go. Again, I can only cancel them out if they're on both sides. If I just told you the volume was 96, you're not canceling pi out. You got to divide it out eventually. All right, so don't cancel them out unless you got one apiece on each side. So now I got 96 equals 1/3 r squared times 8. I'll let you guys go from there. Get r squared by itself. There's a couple moves you can make in any order. All right, let's quicken it up here. I got r squared equals 36. Let's keep going. R equals 6. Hopefully you didn't box that in because remember we're finding the diameter, right? And Zoli's conversation, hey, got to double it. So diameter 12 centimeters. Okay, 12 centimeters. All right, one more big dog one on our own, and then I'm giving a big dog one to you and your group to do. Oh, cylinder coming back from yesterday, it looks like. All right, so everyone sees my cone. I'm going to fill that cone completely with water. Pour it in the cylinder. Fill it again. Pour it in the cylinder. How many of these cones do I need to fill with water before it fills up the cylinder? But cylinder can't overflow. Okay, so how many full cones can I pour into this cylinder so it doesn't overflow? That's the question in a nutshell. And how do I know this is volume versus surface area? I'm pouring it inside, right? And I showed you guys yesterday going inside, it's all volume. All right, so take a minute right now. You can go ahead of me if you need to. Find the volume of the cone and find the volume of the cylinder. And then we'll figure out how many cones could go into the cylinder. All right, so cone, just to make sure you guys start off on the right foot. One-third. Nobody's plugging in 5, I hope, for the height. That's slant height. Use your Pythagorean theorem to find out what the actual height is, the altitude. Everyone getting 4? Using Pythagorean theorem, 4 for the height. Don't round your answer for your volumes, right? Your volumes are not your answer. Do not round those volumes. Look back on your formula sheet if you forgot cylinder from yesterday. Make sure our volumes match. And I see some of your papers, you left it in terms of pi. That's fine too. That's fine. If you don't want to write the decimal, you could have left it in terms of pi. All right, now let's try to figure out how many cups. Is everyone good with the calculations? All right, so again, before I reveal how to find out how many cups, right? So this cone can fill about 37.7 cubic inches. I pour it in, another 37.7, pour it in, another 37.7, pour it in, but this can only hold 355.9. So what do I want to do with these two volumes to find the number of cups? I want to divide them. Okay, I want to divide. You end up multiplying. That's a lot of cups. All right, and there's no way you're going to go way over the 351 you can hold. So you take your volume of your cylinder divided by the number of your volume in your cone. Now let's talk about your answer here. Because I know usually we've been doing problems like paint can problems, where it's like, oh, if I had 3.1, I need 4. Right? If I had 4.8 bags, I need 5 bags. Well, not here. What are you guys getting? About 9.3. You're getting about 9.3 cups. You go 10 though, what's going to happen? It's going to overflow. It can only hold literally 9.3. So if you go 10, it's going to overflow. So how many full cups is it going to be? 9. All right, makes sense why I don't want to go to 10. It can only hold 9, and I can't do 0.3. That's not a full cup. All right. So that's why I got to go 9. All right, you and your groups now. I really don't want to say a word about this next one. All right, you're going to have to grind away. It involves, I'll hide all my work up here. Just so you guys, I'll quickly go through this with you. Probably you have no idea. Anybody know British thermal units? Heard of that before? Probably not. That's fine. It's a way to heat your house. All right, it's a way to heat your house. I want to know how many BTUs are needed to, what are we doing here? To cool the room, all right? To cool the room. How many BTUs do I need? Up top, you have a triangular prism, which we did yesterday. On the bottom, you have a rectangular prism, which we did yesterday. Okay, 2.5 BTUs for every cubic foot. So you're going to have to find the volume of that house first in your group, and then figure out how many BTUs you're going to need to cool the house. You can talk it over in your group. You're going to have to find the volume of the triangular prism and then find the volume of the rectangular prism. Add them together and then figure out how many BTUs it's going to take. Can I give you, I'll give you one piece of information. The triangular prism, right, is what? BH. That's BH, that's the formula for a prism. So you're going to have to find the area of one of these triangular bases for big B. What's the height of that prism? The prism. What's the height of the prism? This edge that connects the bases, right? The edge that connects the triangular bases. So yes, Cormac, it's going to be 24. That's the height of the triangular prism. That's going to be H and BH when you do the triangular prism. But you got to find the area of the triangle too. All right, let's see. It's okay. Hey, if you make mistakes, fine. You're trying it though. Talk to people in your group if you have to. And don't forget to read the part about the windows. You need a little extra BTUs at the end for your windows. You got this, guys. Come on, dig deep. I got faith in you.
Is that how you do a triangle? Maybe just
All right, looks like we got to talk about it, huh? All right, real quick, let's talk about the volumes. Hopefully you didn't have any issue on the volume of the rectangular prism. All right, volume of the rectangular prism, 3,888. Okay, length times width times height. That was fun. Sorry. Sometimes it does magic things like fill in my coffee for it. And then sometimes it just craps the bed. Okay, going back, sorry. All right, so 3,888. Make sure we got the triangular prism down. B is the area of a triangle. Look, 1/2 base of that triangle is 18. Height was 6. All right, so that's why big B is 54. 1/2 base times height. And we just went over height of the prism, 24. So we should have got 1296. Add them together. Total volume, 5,184. All good. All right, now take that number, find how many BTUs you need. There's 2.5 BTUs per cubic feet. If you don't know if you have to multiply by 2.5 or divide, you guys know what I want, a proportion. 1 cubic foot equals 2.5 BTUs. Put your 5,184 under cubic feet, solve for how many BTUs you need. And you end up multiplying by the 2.5, not dividing. So we keep going. So when I multiply, I end up needing 12,960 BTUs for the house. But now we got to include the 4 windows, right? 4 windows, 1,000 BTUs apiece. That's why you see me adding in 4,000 extra ones there to the 12,960 for a total of hopefully 16,960 BTUs. That's where we're going in this unit. Okay, that's where we are. That's where the test will be.